Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, let's have a look at that unit circle in action. So question 4, 2018. Find all values of x for which cos 2x equals minus root 3 over 2 between 0 and 360 degrees. Okay, so not that you need to be able to do it, but I'm going to draw you a picture. So building on the trig functions that we drew, okay? Remember our a plus b cos x, okay? So I see 2x here, which means cos 2x, okay? So cos function starts high. Okay, so there's one cycle, there's two cycles. So when I see this 2x, I know that there's two cycles between 0 and 360 degrees. Okay, and I know that from cos 2x, okay? Because remember, this number here in front of x gives us the number of cycles in a 360 window. Okay, now we have value minus root 3 over 2. Okay, I'm just going to put that into my calculator just once, just to decimalize it. So minus 0.866. Okay, I also know that this cos has a range of 1. Okay, 1 to minus 1. Okay, because remember the b, the number in front of sine or cos, was the amplitude. Okay, where was I going with that? Yeah, so root 3 over 2 is minus 0.66. Okay, so if I find that on my y-axis, can you see that minus 0.66 is somewhere there? Okay, so let me just draw a line across here. Okay, so I have a point here, a point here, a point here, and a point here. So this question is asking you, find all the values of x. So it's that value, that value, that value, and that value. Find all the values of x for which this wave, cos of 2x, equals minus root 3 over 2. Okay, so you, unless it's a special angle, and a special angle is where it crosses the x-axis, generally you'll have 4 answers for this. You'll have twice as many as the value in front of x, okay? Because the value in front of x tells you how many cycles you have, and typically you have 2 parts on a trig curve for the same value, once when it's going down, once when it's coming up. Okay, so I hope that makes sense. Like I said, you don't have to be able to draw the diagram, but all I'm trying to do is just link those 2 pieces of theory we did. I'll come back to cast again in a minute, but just link understanding a trig function and all the different letters of it and what to expect for your answer, okay? Because now you're expecting 4 answers for x. Okay, so how do we do it? Well, we need to solve for x, okay? It says find the values for x. So the first thing I would do is get cos inverse of both sides, okay? Because that will strip away cos. So let's do that. So I have cos of 2x being equal to minus root 3 over 2. Let's get the cos inverse of both sides. Cos and cos inverse is left, so 2x is equal to. Now, the other thing I'm going to say to you actually, and I'll probably keep doing this as stopping between the question, but you see the minus that's here? I don't use that when I'm using these questions, okay? What I use minus for is location. And when I say location, I mean location on my cast unit circle. Okay, so I'll come back to that in a minute. So into my calculator, I'm going putting cos inverse of a positive root 3 over 2 because I'm looking for the sine of an angle. okay? And I got 30 degrees. Okay, so my reference angle, if I could call it that, and I'll explain why it's a reference angle in a minute, is 30 degrees. Okay, so I draw my cast. Let's see if I can draw a better one than that. I fill in my CAST, okay? And now this is where I use the minus. So where in my unit circle is cos negative? Okay, well, we know all is positive here. We know cos is positive here. So this is the quadrant where cos is negative, and in this one, cos is negative. Okay, so the angle sizes must be between 90 and 180 for cos to be negative here, and they must be between 180 and 270 for cos to be negative here. Okay, so therefore, this is where then the reference angle comes into play. So our reference angle is always with reference to the x-axis, okay? So what you do is you come back an angle of 30 degrees if you're in quadrant 2, okay? So for quadrant 2, it's 180 degrees minus your reference angle, okay? So it's 150 degrees, okay? For quadrant 3, okay, it's 180 degrees plus the reference angle, so it's 210 degrees. Okay, so just explain what I'm doing there again. Okay, in some value in here, if you put in cos of an angle, okay, you're going to get minus root 3 over 2. So our reference angle, we know that from minus 3 over 2. When you need to find out that angle for quadrant 2, it's always 180 plus or minus. If you're at this side, it's 0 degrees plus, or it's 360 degrees minus. So it's never with respect to the y-axis, okay? It's always with respect to x. So that's why it's minus the reference angle for quadrant 2 plus for quadrant 3, and it's always to 180. Okay, so what have I just worked out there? Well, I've worked out that 2x here is equal to 150 degrees. Okay, and I've worked out 2x is equal to 110 degrees. Okay, and it's 2x because it was cos of 2x here. Now I'm not finished yet. Remember we said there was 4 values. So what have I worked out with 150 and 210? Well, I've only found the 2 values on that first cycle of the cos wave. Okay, how do I find out these 2 then? Well, any waveform is cyclic. Any trig waveform is cyclic, or it repeats. Okay, so the distance between here and here is actually 180 degrees, okay? And the distance between here and here is 180 degrees, okay? So how do I suppose mathematically write that down? We can see it in the waveform, but how do we write it down? We write functions above in what's called the general form. Okay, so what do I mean by that? Well, 2x is equal to 150 degrees plus n 360 degrees, or 2x is equal to 210 degrees plus n 360 degrees. So what am I saying there? Okay, well, think about rotations. Think about even just think about the wind turbine that we mentioned in the theory, creating the next waveform, okay? You have to rotate once again to get it, okay? So you end up at the exact same point on a waveform, just 360 degrees on. And you're going to get the same answer for a waveform 360 degrees on from where you are. So to explain that, better than I'm doing there. If you get cos of 30 degrees in your calculator, okay? So try this for me now, just so that I can try and explain what I meant. So if you get cos 360 degrees on my calculator, that's coming out as root 3 over 2. Now, what I want you to do is add on 360 degrees for that, okay? So 360 plus 30 is 390. So now get cos 390 degrees for me, and lo and behold, you get root 3 over 2. Why? Okay, well, let me draw in 30 degrees on the unit circle, okay, if you can imagine that. So that's that angle. Remember I said it's always from the positive side of the x-axis. So there's my 30 degrees. So all I've done is literally added on 360 degrees and I've ended back at the same point. Okay, so when I do it like that, you're not surprised that I get the same value. Okay, so what does the n mean? Well, the n means I can do any number of 360 rotations and I end up back at the same point. Okay, because 360 is a full circle and brings you back to the same point. So what the general form is telling you is that 2x for this particular one is equal to 150 degrees, which is out here someplace, plus any number of 360 degrees rotations. Okay, so I hope that makes sense. So once you have it in this form, then you can divide across by 2, okay? Because remember, we have to solve for x. So divide across by 2, and we get x being equal to 75 degrees plus n 180 degrees, or x is equal to, I should know that, 105 degrees plus n 180 degrees. Okay, and just explain when I said these were 180 degrees apart because we were in a 360 degree windows, this is why I hadn't divided across by 2 up here. So I hope that makes sense, okay? And then you have to figure out, right, how many ends, how many of these do I have to do within the 360 window, okay? So in my first rotation, n is 0. In other words, I haven't done any rotations yet. I'm still on my first one, okay? So that's why we let n equal to 0 to find out our angles in the first cycle. Okay, so when n is equal to 0, x is 75 degrees and x is 105 degrees. Okay, if you think about it, 75 degrees, well, yeah, no, I leave that. And then when n is equal to 1, we're on our first rotation. So we have 1 done and we're over here. So we get x being equal to 75 degrees plus 180 degrees. So 180 plus 75 is 255 degrees, and x is equal to 105 degrees plus 180 degrees, which is 285 degrees. Okay, so the 4 answers, and I have left myself without space to write it out, so I'm going to write it up here if that's okay. My 4 answers, x is equal to 75 degrees, comma, 105 degrees, comma, 255 degrees, 285 degrees. And they correspond to that value there on the x-axis, that value there, so that's 75 and 105, and then 255, 285. Okay, so they are all the values of x for which cos 2x equals minus root 3 over 2. Okay, if you add on another n is equal to 2, so some teachers get you to do n is equal to 2 until you break or you become greater than 360, and then you discard it because you're outside 360. Some teach it that way. There's no need though to go to it if you understand that you will have 2 rotations here, so 4 values is what you'd expect. If you've enjoyed this video, then why not join us in IT Sligo and use Maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in Maths to qualify. Check out the link below.